Hey there and welcome. We're going to take a tour inside that machine you're probably using right this second. And trust me, by the time we're done, you'll know exactly what's ticking away inside that box.
You know, it really can feel like magic, can't it? You click a button and boom, a whole universe just pops up on your screen. But here's the thing, it's not magic at all. It's actually this incredible team of components, all working together in perfect harmony. And today, we're going to meet the whole crew. All right, so let's just dive right in. I think the best way, honestly, to really get how a computer works is to build one. So that's what we're going to do. We're going to assemble a computer from the ground up, piece by piece, starting with the most fundamental parts. So, where do we even begin? Well, with any build, you've got to start with the essentials. For us, that means the skeleton and the brain of the whole operation. First up, we've got the motherboard. Seriously, think of this as the foundation for everything. It's the skeleton that gives the computer its structure for sure, but it's also kind of like the body's central nervous system. Every single part we're about to talk about, it plugs right into this board. It's how they all communicate with each other. And what's the very first thing we're going to slot into that motherboard? The CPU, the central processing unit. This is, and I mean this, the absolute brain of the whole operation. It's the powerhouse doing all the heavy lifting, crunching the numbers, and following all the instructions that make your programs actually, well, run. Now, just like our brains, not all CPUs are created equal. You'll see a few key specs that tell you how powerful one is. There's clock speed, which is measured in gigahertz. You can just think of that as how fast it thinks. Then you have cores. The more cores it has, the more things it can handle at once. It's literally like having extra brains for multitasking. And yeah, pretty much everything you'll run into today uses a 64-bit architecture. That's just the modern standard. Okay, so we've got a brain and a nervous system. But how does it even know how to wake up in the morning? That's where firmware comes into play. It's this small piece of permanent software that lives right on the motherboard, and its only job is to give the CPU its wake-up call, the very first set of instructions when you hit that power button. All right, our computer is really starting to take shape. But, you know, a brain isn't much use without any memory, right? So next up, we have to give our machine a way to remember things, both for the short term, like what it's working on right now, and for the long haul. So first, let's talk about RAM, which stands for Random Access Memory. The absolute best way to think about RAM is like your desk space. It's the computer's temporary short-term memory that holds all the applications and files you have open right this second. The more RAM you have, the bigger your desk is, meaning you can have more things going on at once without everything slowing to a crawl. But here's the crucial thing about RAM. It's volatile. That's just a fancy word meaning when you turn the power off, poof, everything in RAM disappears. It's like clearing off your desk at the end of the day. So for all the stuff you actually want to keep, you need non-volatile storage, the kind that remembers everything even when the power's off. And that brings us to our computer's filing cabinet, long-term storage. You basically got two main flavors here. There's the classic hard disk drive, or HDD, which uses spinning magnetic disks inside. They're cheaper, but they're also way slower. The modern option is the solid-state drive, or SSD. No moving parts, it just uses flash memory. It is so much faster, but it is a bit more expensive. Okay, quick pop quiz for you then. Based on what we just said, what is the fastest long-term storage option? Yep, you got it. It's the SSD. That flash-based tech gives it a huge speed advantage over the old mechanical hard drives for booting up your computer and loading your files. All right, our computer has a brain and memory. It can think and remember. Now let's give it some senses so it can actually interact with the world. We need to give it sight and a way to communicate. To give our computer sight, we need a GPU, the graphics processing unit. You can think of this as a second, highly specialized brain that is totally dedicated to creating images, animations, and video. So whether you're playing a game, editing a video, or just seeing your desktop on the screen, that's the GPU acting as the computer's eyes. And for communication, we have the NIC, or Network Interface Card. This is the component that lets your computer connect to a network, either with a physical cable or wirelessly over Wi-Fi. It's the machine's voice and ears, allowing it to talk to the internet and to other devices. We are so close now. We've got the brain, memory, and senses. But none of it can work without its life support system. It's time to power this whole thing on. This is the support team, the unsung heroes. First, The power supply unit, or PSU. It's basically the heart of the computer. It takes the power coming from your wall outlet and converts it into the stable, direct current that all these components need to live. And second, the cooling system. All these parts generate a lot of heat, so the fans and heat sinks act as the lungs, keeping everything cool and preventing it from overheating. And just like that, we've done it. We've assembled all the core pieces. We've taken this whole collection of specialized parts and turned them into a single, functional system. Let's do a quick recap. This lays it all out perfectly. The motherboard is the skeleton and nerves connecting everything. The CPU is the brain doing the thinking. RAM is your short-term disk space memory, while storage is your long-term filing cabinet memory. The GPU gives it its eyes, and the PSU and cooling system act as the heart and lungs, keeping the whole thing alive and stable. So the most important thing to remember is this: your computer isn't some unknowable magic box. It's a team, a highly efficient team of specialized components where each and every player has a vital role that allows the whole system to function. And that leaves us with a final thought. Now that you've been introduced to the team inside your machine, if you wanted to boost its performance, which player would you choose to upgrade first? The brain, the memory, the eyes? The cool thing is, now you know enough to answer that, and the answer depends entirely on what you want your computer to do better. Thanks for watching.